Apart from Farzana, who was there? Haripriya, can you recall the
It
name?
was Pallavi ma'am, and Pallavi ma'am couldn't do because she was
Yeah,
traveling.
she wrote that she's traveling.
And it was Chitra ma'am, but I couldn't get any response from Chitra ma'am.
Okay, probably maybe.
Again, bus.
So I'll
Yeah.
show. Farzana, do you want me to show?
इसमें interaction show करना है.
No, I will let them first learn the estimated marginal mean. Okay, this is binomial. So Haripriya, you were saying that I have to show
Last
what?
one, ma'am, you had to show the predictor
Okay,
and
this one.
this one, these both.
Okay, so if you like
Press.
click on data, okay, I think Cook's distance.
ये प्रोबेबिलिटी चेंज करता रहेगा नंबर ऑफ वेरिएबल पे. नंबर चेंज करेगा ये सब.
So this is the predicted probability and this is the Cook's distance. So for Cook's distance, you just have to click the last option of save and then it'll show the Cook's distance here. The predicted probability is this. So you can just match the status with the predicted probability. So if predicted probability is 0.7, 0.9, that means the surgery is cancelled and actually is also the same is there. So true. Again cancelled and 0.7. So there's no mismatch. Done and 0.169, no mismatch. Done and 0, no mismatch. Cancelled and this all same. If you see the mismatch, then I think mismatch was in the cancelled. It is cancelled, but again 0.167. It is cancelled, but it is 0.123. So these two are mismatch. This one and this one. And if you go down, if you see like cancelled, well, and if the predicted probability is less than 0.5, that means there is a mismatch. Why? Because according to the prediction, it is a done one. 0.167 means surgery done, but actual membership is surgery cancelled. So that's why that's the mismatch.
So I just wanted to say to my participants, you have to see that in the data session.
In
Actually, they were
the
searching for in the right hand side where the graphs
this
were
one, this
coming,
one.
tables were coming.
Here
So
it will
yeah,
not show.
it will not show. It will have to go to the data and you have to check.
And there is no need to. That is just to make them understand the way we have learned the theory. In theory, we have learned now, like it calculates the predicted probability based on maximum likelihood estimation. So that predicted probability was calculated using MLE. And now based on that MLE, actually you have to see like what is the mismatch. And that's how your, model improvement over the null. Means if you give this, the predicted variable, how much improvement over the null model you can predict. So that's why the McFadden R square or the other type of R square like Cox and Snellen and the Nagalkar. Many time you can report Nagalkar R square also because Nagalkar R square, if you see the value is 20. So 20, it says that if you just want to talk about the variances, then this Nagalkar R square is a good one because Nagalkar R square is said that 20% of the variation in this that predicted probability is due to all these factors. That you can say. But if you want to use the McFadden is used mostly when you are using model, making like prediction. But if you are just showing the association and magnitude of association, then you can go with the Nagalkar R square, which tells about the variance. It doesn't tell about the model. But here, this McFadden is specifically for the model improvement. 14 means 14% improvement from the null model. Null model means it only has the intercept and apart from the no variable. But if it is having the independent variable, then there's a 14% improvement. So if your aim is only to have association, then you can go with this Nagalkar R square also, which is 20% in this case.
Ma'am, I want to ask something.
I think your
Thank
voice
you,
is
ma'am.
very low. Okay, you are welcome, Haripriya. Yeah, can you please little louder?
Ma'am, am I audible now?
Namrata, yes, I can. I can hear you.
Ma'am, Nagalkar R square, if it is 20%, then it is considered good.
Yes, good means you want to say whether it is good or not. That way you can, that comment you can do from this p value also. Overall p value is also good. It's significant. So you can comment from that also. And this is also good, like 0.20% is a good explanation. And these all variables are also significant, which you have taken in the final one, except for I missed on the admission type. I think later I have included that admission type. Yes, so now it is there. So you can show that admission type and see. So all these variables are significant. If you see the p-value, this age is significant, gender is significant, the department, one department is significant, admission type significant, regional anesthesia, all these are significant. Although this is not a true data. I said that this we have created for the purpose of workshop. This is not a true data. But again, if it is the true data, then all these variables in the model, the p-value is significant, the odds ratio. Okay, Namrata?
Yes, ma'am.
Okay. So if you have done now, the next is I have to show the what that I adjusted this estimated marginal mean. Okay. So first I'll explain that. So what is the estimated marginal mean? We have learned the estimated marginal mean in the linear regression also. So it is basically in case of a logistic regression, although the term is estimated marginal mean, but this is not the mean value. It is the probability. It is the adjusted probability. So what do I mean by adjusted probability? In the upper this table, we only express it by the odds ratio. But if you want this value to be communicated in the form of a probability, then you can use the this estimated marginal mean. So if I move this gender across here in the first term, and then there is something known as the marginal mean plot and marginal mean table. So I have clicked on these two options, marginal mean plot and marginal mean table. And if you see here, this is the marginal mean plot. And if you see the marginal mean table, this is the probability. Means probability of surgery cancellation in female is 8%. After adjusting for all other variable, because this is adjusted one, estimated, why it is known as the estimated marginal mean? It is the adjusted probability of a particular event. So probability of a surgery cancellation in female is 0.8% and probability of surgery cancellation in male is 21% with the upper and the lower 95% confidence interval. And what Dr. Farzana was asking regarding the adjusted relative risk or the risk ratio. So that is possible from here since this is the adjusted probability. So if you want adjusted, because this relative risk is the ratio of two probability. So like we just discussed, me and Dr. Shamshad, and it is like if you want to give the relative risk of surgery cancellation in male, taking female as a reference, then it would be like 21 divided by 8. So this would be your adjusted relative risk of surgery cancellation in male, taking reference of female. Farzana, are you there?
Yes, ma'am, I got it. It's really a great idea. We can calculate from this table.
Yeah, and like you can although I don't know whether other if you can go and see in the here. If we have learned this in the chi-square association, where if you move these two, surgery cancellation, that will be your unadjusted one. Surgery status because this is your dependent. So dependent will go in column and gender is in row. So gender I'll move to row. And then in the 2 by 2, if you click relative risk, so this will be your, if I click on row wise percentage, so this will give you, if you here whatever value you see 1.24. So the relative risk here will be this value because you have to see the cancellation. So it gives you the value here, the first one. So here I will have to change the reference. Why? Because whatever is the value, it gives you the first done. relative risk of surgery done. So this 1.24 is the 89% by 72%. So for that, you need to go to the variable. Let me go to the variable. And from here, you will have to change the gender. So gender, just a sec, surgery. This, you will have to move this up. So now if you see, so this 0.40 is the cancelled. That means 11 by 28. That is 0.40 in female, taking reference as a male. If you have to change the reference also, then from there the same, you can change the reference also. So like you can go to this gender, and then because here you cannot change the reference. In relative risk, there you can change the reference. Means from the ordinal or from the. So now this is telling the relative unadjusted relative risk of surgery cancellation in male, taking the reference as female. And if you like come up,
And ma'am, it's we can see significance from the CI or
yes, you can see the significance from CI. It also gives you CI, and there also, if you go to the and this is the you can calculate like 21 by 8. So 21 by 8, it will be like 2 point something. If you calculate from the calculator, you can do that just since you've asked. So 2.6 will be your adjusted. And similarly, you can calculate for these confidence interval also, like 13 by 5 and 32 by 14 CI.
लेकिन ये चेंज होता चला जाएगा जैसे जैसे आप चेंज
Okay, but again you will have to specify the variables, because the moment you will change the variable here, this will change.
okay, ma'am.
This is regarding the estimated marginal mean. So what is estimated marginal mean? Basically, estimated marginal mean is the probability, the adjusted probability of a particular outcome. So the outcome here is the dependent variable is the surgery cancellation. So this gives you, like, if I change this gender to some other variable, if you want, like generally it is done for categorical variable. So like if I do it admission type, if I put that value, and if you see the probability, because many times it is difficult for a common person to understand in terms of odds. So now you can see the probability of cancellation in OPD was 42%, and probability of cancellation in IPD was 3%. So this is the meaning of adjusted probability or the estimated marginal mean. And then one part which I could not tell, that was regarding how to write the interpretation. So table, we will modify it. Let's see if we can. Because tomorrow is also there's a session. And then this is the write-up. So write-up, you can see you have to write the assumptions also. I think we have shared this. We have shared this, no? Write-up. So you can just see how we should write the interpretation. You can go through it and you can see. Okay, so this you see how we do the interpretation. So any question up till this point? Otherwise, we will go to multinomial logistic regression. Let me see the chat. Okay, 2.62, Dr. Suresh is saying. Yes, Dr. Suresh, you are right. Should we move to multinomial logistic regression? Okay, with no response, then yeah. So multinomial logistic regression, till now in binomial logistic regression, what did we discuss? That the dependent variable, it has got two levels. That means either it is in the form of yes, no, or any other, like outcome happened or not happened. So outcome or the dependent variable. Outcome, what do you mean by outcome? That the dependent variable has got two levels. But what to do if we have got more than two levels? So if we have got more than two levels, in that case, we'll see what are the variables, what are the various types of variables where we can see more than two variables. So if these are the variables, the first variable is a choice of contraception, where the various categories are the oral contraceptive pill, copper T, and medroxyprogesterone acetate. If my dependent variable is pain, then my categories are like mild, moderate, and severe. If my variable is the preferred method of follow-up, and my various categories are the telephonic, in person, or by mail. If my variable is vaccination status, but my categories are not vaccinated, partially vaccinated, and fully vaccinated. If my variable is tumor grade and the grade is 1, 2, 3, 4, and if my dependent variable is the preferred teaching method, and the various categories are the PowerPoint, chalk and talk, and interactive board. So in all these 6 variables, which are the variable which is there in their natural order? That means ordinal in nature. Yes, please type in the chat box. So pain, right? Any other apart from pain? Tumor grade, yes, right? What about the vaccination status? Yes, because vaccination status is again like non-vaccinated, partially and fully. That is in its natural order. So out of 6, 3 variables, pain, vaccination status, and tumor grade. That is like a natural order or like ordinal, and the rest 3, like choice of contraception, preferred method of follow-up, and preferred teaching method. That is nominal. That means that is not in the natural order. So if variable has got more than 2 levels, the dependent variable. Here we are talking about the dependent variable. So if the dependent variable is having more than 2 levels, it is known as the polytomous variable. So in polytomous variable, we look for order in like we should look for orders or the categories. If there is a order or the ordinal variable, then the choice of regression would be the ordinal logistic regression. If there is no order, like we have just seen the choice of contraception or preferred teaching method, then it would be a multinomial. So when there is no order, it is multinomial. When there is order, it is the ordinal logistic regression. So how to do the analysis in such case where the outcome has multi-level? So one is like simple approach is like you can club them and make out of 3 you can make 2 categories, or out of 4 you can make 2 categories. Like you can club the copper T and marina together, and you can take one as a OCP. So these will be 2 levels. Again, you can club grade 1 and 2 as one, and grade 3 and 4 as one. So that 4 levels, basically what you are doing, you are converting them to 2 levels. Because if you don't wish to go for multinomial logistic or ordinal logistic, then you can club them into 2 categories and you can run a binary logistic regression. Okay, like you can again have one as a mild and other as a non-mild. Non-mild means moderate and severe together. Similarly, one you can have like in person and the rest 2 telephone, non-in person means telephonic and distant conversation or distant communication. So how you are doing? Basically, so we are telling you how to tackle if the dependent variable has got more than 2 levels, what all options you have so that you can go for a regression. So either you can do this. So like similar, you can see 0, 1 and 2. So you have club 0 and 1 together and 2 separately. So you have got 2 categories. Or if you have got like mild, none, mild, and moderate, severe, so you can club none and mild together, having one category, and moderate and severe together, having another category. Now, what is the disadvantage of dichotomizing such type of, if there are 4 levels or 3 levels, what is the disadvantage of like reducing the number of categories? Yes, please type in the chat box. Comparison of moderate and severe. Yes, that will not be done. If you club the category and if you want to know about the moderate, comparison of moderate and severe differently, then you cannot do. What can be the other problem? One very important problem is that there will be loss of data. Means generally we say that if you club category, there will be loss of data. So there will be loss of data in this case also. So now next simple approach is like if my outcome has got k levels, then I can develop k models. That means I can convert again multinomial to many binomial variable. Like I can make one binomial with in-person versus telephonic and email. One again email. I think there is just a sec. There's a echo. Is the echo still persisting? No, it's okay now. So what can you do? You can convert these multinomial variables to many binomial variable. Like you can run separate binary. There was echo हो रहा है.
कट गया आपको इसे
लगातार constant echo was happening.
या नहीं लगा
That's okay. So you can run so many binomial logistic regression, but what will happen? So you can compare A versus B and C versus A and B versus C and A. So we have 3 models for 3 category or level, but if you see the probability, if you see this equation, so this equation will give the probability of for this outcome A. This equation will give you the probability of outcome C, and the third equation will give you the probability of outcome B. But in this all case, if you like add these 3, the probability will be more than 1. Because if you add all these 3 probability, it will be more than 1. But for an individual case, the total probability sum should be equal to 1. It should not be more than 1. That's why if we run a binomial logistic regression separately, it leads to error, increase in error, and because there is an increase in probability and the value of probability becomes more than 1. So that's why we cannot run these separate binomial logistic regression. This is same as like, when we compare ANOVA versus independent sample t-test. So we say that if you run the many independent sample t-test between, if there are more than 2 categories, it leads to inflate high alpha error. Similarly, here also, if you run so many binary logistic regression, it is not practically possible because it will lead to a total value of total probability more than 1, and it will cause in the increase in the standard error estimation. So that's why there will be increase in error, and that will not be a good idea. So that's why you should not run separate binomial logistic regression for the multinomial variable, treating them like that. So then what is the solution? So then there's an option which is the multinomial logistic regression. You can use this option of multinomial logistic regression if your variable has got more than 2 levels, the dependent variable. So now what happens in the multinomial logistic regression? Like in this example, if my dependent variable is having 3 levels, in person, telephonic versus email communication. So the multinomial logistic regression that assigns, like it takes one level as reference. That means if it may take in person, that you can change in the setting. The reference value can be changed in the setting. So in person, it will take as a reference, and then it will compare telephonic versus in person, and then it will have another email versus in person. Means if it takes in person as a reference, then it will give you two model. One model will be comparing telephonic versus in person, and another model will be comparing the in person versus email. And then again you can have those two models in your case. So for k levels, the multinomial logistic regression will make k minus 1 model. What do I mean by that? If there are 3 levels, if it will give you 2 models. If there are 4 levels, it will give you how many model? 4 minus 1, 3 more. So this is how it will give. We will see that when I'll start doing it, I'll demonstrate this. So don't worry if you're not getting this number of k and k minus 1. That simply say that if there are k levels, then it will give you k minus 1 model. So now let's see. Not of much theory in logistics, this multinomial, because multinomial it doesn't have any other assumption except for that the variable should be multinomial in nature. And one more thing is that if the variable is nominal and still you want to go for multinomial, that also you can do. But there the natural order of the variable, it doesn't treat that natural order of the variable. So I'll show the question and how. So this was the article which we have shared. Multinomial logistic regression. So assessing prevalence factors related to frailty in community dwelling older adults, a multinomial logistic regression analysis. If you see, this is the abstract. They have 582% age 65 year or more. They have participated in this cross-sectional study. This is a study from Spain. And what are the variables they have taken? They have taken the variables like polymedication, other factors, gender. The study variable mostly associated with frailty was female gender. Other factors found to be associated with dependence is the IADL, polymedication, osteoarticular pathology, psychopathology. And then again, as the age was increasing, frailty was increasing. So their dependent variable is the frailty status. And how they have measured the frailty, we'll see. Study design, data collection, measuring. So they have frailty assessment. If you see frailty assessment, the main study outcome was frailty, assessed by phenotype proposed by Fried, and it consisted of following criteria: unintentional weight loss for 4.5 kg or more in the previous year, self-reported exhaustion identified by 2 questions in the Center of Epidemiological Studies depression scale, weakness defined by low hand grip, highest for 3 consecutive management, adjusted for gender and BMI, and slow walking speed and low physical activity. So all these together on a scale, they have classified the scale as 3. 3 means they have like put 3 classification: frail, robust, and non-frail. So participants were classified as non-frail if they met none of the criteria, and if they met 1 or 2 criteria, frail, and 1 or 2 criteria, then pre-frail, and then frail. So there were 3 levels: robust, pre-frail, and frail. So if you see the nature of variable, is it a nominal variable or is it a ordinal variable? Yes, please type in the chat box. So Dr. Hilda is writing nominal. But Dr. Hilda, how it can be nominal? Because there is a natural order. Robust, pre-frail, frail and frail. So if there's a natural order, it is a ordinal. So ideally, the choice of logistic regression in this case should have been ordinal logistic regression, because the dependent variable is having natural order. So if there's a natural order, ideally it should be, but it is again the researcher choice. I'm not saying that they should, because we will see in the ordinal logistic regression tomorrow that there is an assumption of proportional odds, and if that assumption doesn't meet, then you have to go for multinomial in case of ordinal logistic regression also. So I don't know whether they have tried for ordinal or not, but if the proportional assumption odds is met, then you should go for ordinal logistic if there is a natural order or if the dependent variable is ordinal in nature. So then we can see here. So again, statistical analysis. If you see the statistical analysis, so they have identified this. Exploratory data analysis and frequency table are used, taking account of the three possible state of frailty. A multinomial logistic regression was used to study the relationship between the independent variable and the outcome variable. All independent variables were included in the regression model. The influence of various factors on the state of frailty and pre-frailty was examined. So basically here their aim is not to make some model or something like that. Their aim was only to study the relationship. If you see, study the relationship between the independent variable and the outcome. So I'll go again. If you see how they have expressed the result. And this article we have used, I'll show the result later. First, let me explain the data. So this is your, this we have shared the sheet. How they have classified. So this is variable. Objective was to assess the factors associated with the different frailty status, which was robust, pre-frail and frail. In the community dwelling, the dependent variable in this case is the frailty status, which is a categorical in nature. And the independent variable are the age, which is continuous in nature, gender, which is binary, male and female. Then I have taken the activity of instrumental activity of daily living, which is again on ordinal scale 0 to 8. You can treat any ordinal scale if the levels are more than 5, 5 or equal to more than 5, then you can treat them as a continuous in nature. Heart disease is a binary variable, yes and no. Diabetes, yes and no. Respiratory disease, yes and no. Bone and joint disorder, yes and no. And polypharmacy, again, yes and no. And polypharmacy, they have defined polypharmacy as taking 5 or more medication as polypharmacy. So we'll see how we will do. So I'll go to the data set. So this is the data set. Let me delete all this, remove. So if you see the variable, I'll just explain. This is the gender. 0 is female and 1 is male. Age is a continuous in nature. IADL, it is again continuous. Heart disease, no and yes. No is 0 and yes is 1. Diabetes, no and yes, 0 and 1. Respiratory disease, again, no and yes, 0 and 1. Bone and joint disorder, again, 0 and 1. Polypharmacy. And frailty, I have defined as 3 levels. You can see here. So you can see 0, 1 and 2. So 0 is robust, pre-frail is 1 and frail is 2. This is my dependent variable. That's it. So this is the data set. Now how the option of this multinomial logistic regression will come. And again, the all those theory, like how you will choose the initial selection of variable, how you will put it into the model, that will be the same. So coming, this is regression. We have done this binomial. Now this is the multinomial. I'll click on this multinomial. So if you click on this multinomial, this window will appear. This is again very much similar to the way we have seen earlier. So how you can do that? This is again same. You will do it first one by one. And that means unadjusted. So how you will do? You will put this frailty status as a dependent variable and you will start at gender. So gender, I'll put it is in the factor. So if you see in the one by just it gives you two model. That means, see, this is our first model. Means there is a frailty status, means it is taking robust as a reference criteria. So my reference criteria is robust. So how I will interpret this unadjusted one? If I am focusing on this model, let me first click the model coefficient. So this is my odds ratio. I'm not putting the 95% confidence interval now. So how I will interpret this table? First, see this. These are the two model. First, it gives the odds of pre-frail taking robust into the as a reference level. So how we say if the odds ratio is 1.31, we say that odds of male being in the pre-frail category is 1.31 times as compared to female. So this is your unadjusted odds for this model. Similarly, the unadjusted odds for frail. So if I have to interpret this one, I'm not seeing the p-value. P-value, it is not significant here, but here it is borderline, you can say 1.71. So how I will interpret odds of a male falling into the frail category. Odds of a male falling into the frail category as compared to robust will be 1.7 times. That means male will be more frail as compared to the female. So there are two reference level here that you have to understand. Falling into frail as compared to robust and male as compared to female. Are you getting my point? How you have to interpret it? Yes or no? That's why I'm only telling you with one variable.
Ma'am, you mean to say that 1.31 odds of male are pre-fail compared to robust? That way also, is it?
Yeah. This 1.31 will be the 1.31 times higher odds of falling into the pre-frail of this male. So you take both the first, you say both the first category. Pre-frail, it gives you the odds of male falling into the pre-frail category. So odds of male as compared to female and odds of falling into pre-frail as compared to robust. But that's the second part is like it's there. Yeah. You
So
wanted
it
to say?
means to say practically that frail people are more when compared to robust people.
No.
Among the male, frail are more when compared to robust. Is that making sense, ma'am? What I'm saying?
That if you want to say like that probability, then you have to go to this marginal mean plot. If you want to say they are more, that means probability. Then you click on the marginal mean table and put gender here. But since I have not put anything else, for that, if you want to say like they are more, because here we are saying like odds will be more. let me. It will tell you like this. A female falling into the robust category, the probability is 48%. A female falling into the pre-frail category is 40%. A female falling into the frail category is 13%. A male falling into robust is 40%. A male falling into pre-frail is 43%. And a male falling to frail is 18%. If you want to talk like more and less, it will be that. Proportion. Because this is your probability or the proportion. But here you have to use the term odds, and that too with a reference to another level. So here I cannot say, I will say that odds of a male falling into a pre-frail is 1.31 times. That much I can say. Yes, indirectly you can say like male will be more frail, but exact probability, the male, if you want to compare male frail and female frail, then you can see female will be frail 13% and male will be frail 18%. So this is the adjusted one. If you don't want to take the reference category, then you can use this. But generally you will see, like in most of the tables and the literature, they give this table, like this odds ratio in the two different sets. So here it is giving you two different model. That means it gives you a odds ratio of pre-frail taking robust into as a one reference and frail and robust. So two model. Actually, it gives you, that's what I said. For K model, it gives you K minus 1. For K category, it gives you K minus 1 model. If your dependent variable has got 3 category, like in this case, frailty has been divided into 3 category, robust, pre-frail and frail. It gives you two model, one with the pre-frail taking robust as a reference, and second model is odds in frail taking robust as a reference. So did you get it?
Yes, ma'am. Yes, ma'am. Thank you.
Okay. So have you understood? Other participants, have you understood? Otherwise, this is like I have only shown with one variable. I have not still moved the other variable here in this table. So if like you have to move other, then you can move rest of the variables also, like I'll move age and IADL here, and all other variable like from heart disease, I'll press shift, select all and move here in the factor. And then I'll come down. Reference level, you can see. Reference is the frailty female. It shows you the reference level. And then model fit statistics, the same McFadden. If you wish Nagelkar, you can put. Overall model test, you can see. If you don't want the AIC and deviance, because that is not needed if you are putting all the variables together. This odds ratio and confidence interval I have entered. And that's it. So let's see how to interpret this. It like if it buffers, it takes some time. So now you can see here. This is a bigger, since there are many variables. So the first model, if you see, this is your first model. Pre-frail versus robust. And the other is the second. So if you see the first one, interpretation pre-frail versus robust, if you see the odds ratio. So which all are significant? Let's see the p-value. So this is significant. Age is significant. IDL is significant. Heart disease is significant. Diabetes is not significant. And this respiratory disease is also not significant. Bone joint is significant, and polypharmacy is not significant. So you can only explain the this odds ratio of those variables which are significant. Like for age, you can say with gender. So if it is 0.43, how you will say that odds of a male being pre-fail, it being landing in pre-fail category is 0.43 times. Similarly, you can say about the age. So age with increasing 1 unit increase in or 1 year increase in age, the odds of falling into the pre-frail is 0.43. That means it says that with increasing age, the pre-frail is less as compared to robust. Similarly, the heart disease, if you say it is 1.88, this value is 1.88. So how will we interpret? We will say that odds of a person who is having heart disease falling into the pre-frail category is 1.88 times. Similarly, diabetes, the same interpretation. P-value, it's not significant, so you can leave this. You can again say about this bone joint disorder. So a person who is having bone joint disorder, the odds of falling into the pre-frail category is 1.71 times as compared to the robust. So there, and one more thing, there is no assumption here in the multinomial. Similar interpretation with this frail versus robust also. So if you see the article, let's see the article once again. This was the article, and if you see the table, initially they have given the descriptive, like they have given the descriptive mean and standard deviation of all the quantitative variable, and this is the frailty status according to the phenotype. They have written like robust. This is the like 21% was there as a robust, 54% pre-frail, and 24% as a frail. If you come down, this is the table. So how they have taken these many variables: age, IADL, again the same, gender, diabetes, heart disease, respiratory, bone joint. They have taken psychopathology. We have not taken that, polypharmacy and all. So they have given this. So this frail, they have given frail and pre-frail, odds of frail and pre-frail. But here they have written in the heading, if you see, they have given that multinomial logistic regression for frail and pre-frail state with respect to non-frail or robust. So this non-frail or robust is the reference category. So they have presented their result like that. So this odds ratio which you are seeing, this is the frail versus robust, and this is odds ratio is pre-frail versus robust. So the same odds ratio which you are seeing here, they have presented in the vertical in vertical fashion here with a 95%, and they have given the star like in the which all are significant. So this is also one way of showing it. You can see with the star they have written like these all are significant. This bone joint disorder is significant, psychopathology is significant, polypharmacy is significant in this model but not in this model.
Why they have put for male one, ma'am?
Where?
For the gender?
Well, wherever they are writing one, that means that's the reference criteria, because you will see that in logistic also they put either dash here because it gives you the odds. Like in this case, if you see this table, they have given you like dash dash, only one column, only one row is there. Gender, male and female, if you see this, the odds. Let me go up. So this is the odds ratio. So let's see gender, male and female. So in Jamovi, it writes like male and female like this. And then it gives you the odds ratio 0.43. But what they have done, like if they write one, that means that's the reference category. So all categorical variable, if they are putting one, because there are two reference category in multinomial. One reference category is within the variable itself, and the other reference category is of dependent variable. So the dependent variable reference category, they have written here in the title that pre-frail and frail status with respect to non-frail. So this is one reference level which they have written in the title, and the other reference level they have written in the table. So wherever you can see one, that means that the reference level means this is the odds of female falling being in frail category. This is odds of female in the pre-frail category as compared to male. So these all are like yes, no, no. You will see everywhere no is the one. Can you see? So it's the reference category. It is the same which you see here in the data. Wherever there is no means it's the reference. Jamovi writes like this. All no is reference. And here it is a female. So it gives you the odds of male as compared to female. Whereas if you see the table, they are giving the odds in female. So if you wish to do like that, you can change your reference level. If you want exactly your result, like if you want to compare, then instead of here gender as a female, I will change here to male. So if you change it to male, now it will give you the odds in female, odds of female falling into the pre-frail category. So here, now the reference is male. And now the odds is 2.33. So here now it is the same, because here you will see what the author has given, taken the male as a reference category. And they have given the odds of female falling into the frail category. Can you go a little chat? Okay, so have you understood up till this point why two models and how there are two different reference levels? Dr. Suresh is writing yes. Farzana is writing Priyanka. Okay, all yes. Okay. So if yes, I think again the same concept of estimated marginal mean I have just explained. If you wish to convey in the form of a probability, like gender, if you wish to convey that, let's say, bone joint disorder, then again you can move this bone joint disorder and I can so you can see here that the probability of a person who is having no bone joint disorder, the probability of being in robust is the 0.48, pre-frail is 42, and frail is 10%. Similarly, person who is having bone joint disorder going into the robust is 34%, pre-frail 48, and frail 18. So this is how you interpret the estimated marginal mean. So what are these estimated marginal mean? Basically, these estimated marginal mean are the adjusted probability. That means it is not the raw probability. It is the adjusted probability taking this variable into account. For all other variable, like all other variables are adjusted here. Gender, heart disorder, all other are adjusted. Isolated effect of this bone joint disorder on frailty status. Is it okay to all of you, the multinomial logistic regression? So to some, and this is the law plot. This is the estimated marginal mean plot. This also you can show if you wish to show that as a part of your manuscript or thesis, you can show that. And you can copy paste this table and you can write the result. Let me see if we have written that. So this is the odds ratio, pre-frail and frail. We have also made like that author have made pre-frail and robust and frail and robust. And all those variables. We have not written like one and one. Whatever you write later, that's the reference. So if I'm writing male later, that means that's the reference. And then this is the result. So you can go through that, how we have written the interpretation. It's the same the way I am telling you. And then you can understand what is that. So if you have understood, I think Farzana asked one question regarding some model making. And then we can go to the breakout room. Let me see. Pardon? No, we can have breakout room. We still have time. We will see. Or they can, they themselves will act as a mentor. No? One. So Farzana is writing this comment I received in my document too. Whether I want to see relationship or build a model. Okay. So yes, Farzana, that is a common your purpose of doing a regression is to see the association or to see relationship or to build a model. That you have to decide as a researcher.
Ma'am, when can we decide like I want to build a model for association? I can understand. Okay, I want to see the relationship, but for model, how can I decide? What's the criteria I mean to ask?
For model, one thing is like I discussed in the beginning also, it should be a prospective study. For cross-sectional study, you cannot.
Okay, ma'am.
You
Okay,
should
ma'am.
not.
Okay, ma'am. Got it.
Because model is predictive, future prediction. That should be based on the data which is like collected over a period of time. With one snapshot of data, it is not a good idea to make model or prediction.
So in my case, many of the variables I have a panel data. So in that case, I can build a model.
Yeah, you can. If
Okay.
it is like it is a serial collection over the time, you can.
Okay. And secondly, if R square value is less, then it's not a good model. I mean to say, it's not a predicting, robust predicting. Does it mean that?
R square is less than what value?
If like it's around 6% or 12%, up to 12% I got.
That's okay. Which R square it was? Like
Uh,
Nagal.
I conducted linear regression, I think.
Not very low.
So linear is the variance. So yes, but still you can, whether it is good or not, whatever you have found out, you can just accept that.
Okay.
Right.
3% remaining है ना 6% explain हो रहा है 94% remaining views.
But still as a academic, because I think you are doing a PhD thesis.
Yes, ma'am.
So in PhD, it is not always that it's more of a learning. You are so for learning for academic point of view, even if it is 6% or 12% or whatever, you can just because see you are learning also now how you can apply those principle, how you can check for assumptions. So the purpose of a PhD thesis or a PG thesis is more of a learning. The student should learn all the principles, should start from basic and all those. So you should try all the various thing whatever you have learned to put that in your thesis, and then of course you can, if you are sending a paper, you can select those particular some portion which you think that is important for policy making or for evidence based medicine, those such things, right? But for
True.
thesis per se, yes, definitely you can go with the 6% also. You
Okay.
can say that this is not a good predictor because it is very less, only 6%.
Okay, ma'am. So that type of sentence I can add in the writing part.
Yes, and I always encourage publishing and writing the negative result also, because that's the problem in the meta-analysis. Whenever you try to pull the result in the meta-analysis, you will see all the results which are having all good values. Because if you are having less value, as a researcher also, we are very skeptical whether we should go for publication, and there's a publication bias also. People also, they ask if this is so less, how you can say. But that's the, if you have collected the data honestly, then they are not the predictor. That much only variance they are explaining. There's no harm in accepting that.
Okay, ma'am. Okay, thank you so much, ma'am. Now I get very much clear. Now I am clear, I mean to say.
Okay, thank you.
Thank you.
Okay, so yes, now we are opening the breakout room. All of you practice in the breakout room.